Okay, thanks. So hello everyone, I'm Stefan van Schaik, and today I'm going to talk about RIDL or Dragonfly data load. And suppose we have a machine, this is an Intel Core i7 7800X, and it's one of the machines in the office. So on the first line you see it's a CPU, it has all the mitigations against attacks we've seen in the previous year. So Meltdown, Spectre, Foreshadow, it's all in there. And the question is, of course, we have all these mitigations, so what can we actually do as an attacker? Well, so if we have this etc shadow file and we look at it as a normal user, then we see permission denied. But if we try to look at it as a root user, we can of course see the password hashes. And what we have here is we go back as a normal user, and we have here the RIDL program that actually leaks the password hash from the root account. So meet Dragonfly data loader RIDL, a new class of speculative execution attacks that knows no boundaries. And to show that it knows no boundaries, I'm first going to talk a bit about privilege levels, and privilege levels are just a social construct. So we have different security domains. So for instance, in this case, what I've shown you is that RIDL works on two different threads. So you have a victim thread and an attacker thread, but there are more security domains. So the question is, of course, can we leak across those? So for instance, we have the kernel, and yes, we can leak from the kernel. We leak across VMs, we can leak from the hypervisor, and we can leak from SGX enclaves. So we leak across all security domains. Another question is, of course, can we leak in the web browser? So we also implemented this, and we found out that we actually can. And we reproduce RIDL in Mozilla Firefox, more specifically the SpiderMonkey shell. And what this means is that there's actually no need for special instructions. There's no need for CLFlush. You can just do it in the web browser. We leak across security domains and in the browser. Another social construct I'm going to talk about are memory addresses. So we all remember these logos, Meltdown, Spectre, and Foreshadow. And what they showed us is that we can speculatively leak from addresses. And what that means for our mitigation efforts is that we actually focus on isolating or masking these addresses. So for instance, Spectre shows that you can access out-of-bounds addresses speculatively, so think of an array where you access beyond that array. Meltdown showed that we can leak kernel data from virtual addresses, and Foreshadow shows that we can also leak from physical addresses as long as they're in a level 1D cache. So what are the mitigations? So with Spectre, one of the mitigations is to mask the array index to limit the address range you can access. With Meltdown, we unmap kernel addresses from user space, and with Foreshadow, we simply invalidate the physical address in case we are unmapping a page, for instance. So an example of this is with Meltdown. What does it look like before is that with Meltdown, we had like a single address space with everything inside there living happily. So we had the user space and we had the kernel. And the problem was, of course, with Meltdown, you can leak kernel data from virtual addresses. So what does it look like nowadays? We have two different address spaces, the unprivileged one with the user space, and the privileged one with the user space and kernel memory mapped in. Great. So previous attacks, they exploit addressing, and the mitigation works mostly by isolating and masking these addresses. RIDL, however, does not depend on addressing. And what this means is that it can bypass all security-based, all address-based security checks. And that means that RIDL is hard to mitigate. So what CPUs does RIDL actually affect? Well, we bought Intel and AMD CPUs from almost every generation since 2008. And we sent the invoices to Herbert, to a professor. And this is what it looks like. You could name it, for instance, the Large Hyperthread Collider. And what we found is that RIDL actually works on all mainstream Intel CPUs since 2008. So here's the list of CPUs we tested it on. And then we submitted the paper, and we look at the Intel website, and you see a new announcement of the Coffee Lake refresh, the 9th generation CPUs. And the interesting bit here is that they mention in silicon mitigations against Meltdown and Foreshadow. So we thought, well, let's buy it. We buy the Core i9 9900K, and we send another invoice to Herbert, of course. So it arrives one day after we submit the paper, and it also works. So of course the question is, we don't only have Intel, we also have other companies like AMD and ARM, and we try to reproduce it ourselves on AMD. and we found that RIDL does not affect A and B. So we tried to test it on 3 different CPUs, but they don't seem to be affected. And for ARM, it's also the case that they don't seem to be affected, as we got an official statement from ARM. So nice, RIDL inside, runs great on Intel. But where are we actually leaking from? So here's a part of the Skylake diagram.